Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am chemistry mentor. In today's section I am giving the best trick students, excellent trick to find the bond order, magnetic behavior and molecular orbital electronic configuration. Okay na? Here I am doing the number of example students. Okay, I am going to calculate bond order, magnetic behavior, next electronic configuration. So first I am taking the example students, He2 molecule. First example is He2 molecule. So in He2 molecule, first of all, I am writing total number of electrons. How many electrons are there? He helium atom, two helium atoms are present in the molecule. Two helium atoms. Helium atomic number is two students. Two helium atoms are there. So that's why 2 plus 2 4 electrons. Clear? Two helium atoms are there students, so that's why here helium atomic number is 2. Two helium atoms, 2 plus 2 4 electrons. This is the total number of electrons. Clear this one? So now I'm going to write the molecular orbital electronic configuration. Okay na? How to write the electronic configuration? In electronic configuration students, in the previous videos I told you up to 14 electrons, one energy increasing order, and after 14 electrons another energy increasing order I told you, Nana. So that one just I'm showing you. Listen students, this is first one. This is up to 14 electrons. This is up to 14 electrons, Nana. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2py, pi 2pz, sigma 2px, pi star 2py, pi star 2pz, sigma star 2px. This is up to 14 electrons. Clear? So this is after 14 electrons students. This is the this is the energy increasing order. Okay, now He2 molecule total 4 electrons there, so that's why 4 electrons means it is up to 14 electrons. So that's why we have to write the electronic configuration from here. So sigma 1s 2, what is electronic configuration students? Electronic configuration coming to the electronic configuration students, see here electronic configuration up to 14 electrons, sigma 1s, so right here sigma 1s, 4 electrons in a total, so right here 2 electrons, and sigma star 1s, right here sigma star 1s 2 electrons, then 2 plus 2 4 electrons completed. Understood amma? Sigma 1s2, sigma star 1s2. Clear this one? So this is the electronic configuration, Nana. Now coming to the bond order. What is the bond order of this molecule students? What is the bond order? See here, bond order. So how to find the bond order students here? So here also there is a trick students. He2 molecule 4 electrons there na. So 4 electrons there means what is the trick students? How to find the bond order? See here, how to find the bond order. 4 electrons here. See here. So up to here 4 electrons there, number of electrons 4 there means bond order value how much students? 0. You have to remember this table students, number of electrons, so bond order 1 to 7 electrons. This is the trick, Nana. Okay, it is applicable for up to 7 electrons. So from 8 to 20 electrons I gave you another trick, Nana, another table I gave you in the previous videos. Please once you go through that, Nana. Here number of electrons 4, so that's a bond order is 0 students. 0 is nothing but what students? The molecule does not exist. Are you clear students? So what is the bond order, Nana? So bond order, just you have to remember this table students. Just first you have to calculate the number of electrons to the molecule, then we can 4 electrons came, so that's a bond order is 0. Okay, now if 5 came 0.5. Okay, now 6 came means 1. So like that. So you have to remember this table students, you have to practice, then you can easily answer any type of question. Now see here, bond order is how much, Nana? Bond order how much students? Bond order is 0. Clear? Bond order 0. Okay, now I'm going to calculate. Now I'm going to discuss magnetic behavior students. What is the magnetic behavior here in He2 molecule students? See here, total number of electrons how many students? 4 electrons kada. So total number of electrons 4 electrons. So sigma 1s2 sigma star 1s2. This is bonding molecular orbital. This is anti-bonding molecular orbital. So both are completely filled. Kada? All are paired na. So paired, all are paired. And also we can say that it is the even number of electrons 4 electrons. 4 is the even number. So all even number of electrons students diamagnetic in nature except 10 and 16. Are you clear? See here, even number of electrons. See this trick students, even number of electrons diamagnetic except 10 and 16. These two are exceptional case nana paramagnetic in nature. Odd number of electrons paramagnetic in nature. Clear? So it is even number of electrons diamagnetic in nature. So that's why even number of electrons 4 electron is the even number. It is the even number. So that's why what is happening students, bond order over the magnetic behavior. So magnetic behavior, coming to the magnetic behavior. Tell me students, magnetic behavior, it is even number of electrons now 4 electrons, so that's why it is diamagnetic in nature. Clear? Clear students? Diamagnetic in nature. So this is about the number of electrons. Next, electronic configuration, bond order, magnetic behavior students. Clear this one? So this is about the He2 molecule. Now bond order 0 is nothing but what students? The molecule does not exist. Kada? Does not exist none. Okay. Now see students, second example, CN, carbon cyanide group. See here, CN I am taking CN. Now how many electrons? So first of all I am going to calculate carbon CN. Carbon atomic number is 6, nitrogen atomic number is 7 nana. So total how many electrons? 13 electrons there. Clear this one? So total 13 electrons. Now how to write the electronic configuration? So first I am going to write the electronic configuration students. How to write the electronic configuration? 13 electrons means up to 14 electrons and energy increasing order you have to follow. Okay. So 13 electrons kada. So 13 electrons means, see here, this energy increasing order 13 electrons. 13 electrons. Here here 1s2 sigma star 1s2 sigma 2s2. Here 2 4 6 8 10 12 13. Are you clear? So here you have to, that means in each orbital you have to fill 2 electrons students. Understanding? So maximum in orbital students only 2 electrons can fill. Okay. So only 2 electrons are accommodated in the orbital. See here students, here sigma 1s, sigma star 1s, sigma 2s. Total how many electrons? So 13 electrons. Na? So each orbital you have to fill 2 electrons. So here 2, 4, 6, 8, 10, 12 and one more electron into sigma 2px1. Clear? So how to write? See here students, how to write this one by using this order. See nana, sigma 1s, sigma 1s, sigma star, sigma 1s2, sigma star 1s2, next sigma 2s2, correct? Sigma 2s2, next one sigma star 2s2, next pi 2py2. Okay, it is equal to pi 2py, pi 2py, pi 2pz kada, pi 2py, pi 2pz. 2, next sigma 2px1. Clear? So this is the electronic configuration students. Understood amma? This is up to, this is 13 electrons, that means it is less than 14. So that's it, this energy increasing order you have to follow. Clear? Total 13 electrons, you have to fill the electrons like this, 2 4 6 8 10 12 13. Clear? So in 2px1. Okay, so this is energy increasing order completed. Now coming to the bond order. How to write the bond order students? How to find bond order? Here how many electrons are there students? 13 electrons are there. So here I'll give the best trick students. See here 13 electrons. So just this is the table. Very important students. Just you practice this table. You can easily answer any type of question students. To calculate bond order, number of NBs indicates number of bonding electrons. Na indicates number of antibonding electrons. Okay, now see students, how many electrons we got? 13 electrons we got. See here, where is the 13 electrons? Here, there. Then what is the bond order, students? 2.5. Clear? So bond order is 2.5. So here bond order, without drawing the molecular orbital energy level diagram, students, without the diagrams only, you can just by practicing this table, you can directly write the answer, students. So 13 electrons means 2.5. So bond order is 2.5, students. After that, magnetic nature. Now tell me, students, magnetic nature, how to tell? All even number of electrons. So even number of electrons, students, diamagnetic in nature, except n and 16. Next, odd number of electrons, all are paramagnetic in nature. Now see here, 13 electrons is which one, students? It is odd number, correct? It is a odd number, so that's it is, its a magnetic behavior is paramagnetic in nature. It is a paramagnetic in nature. Clear, students? Paramagnetic in nature. So second example completed. Now we are going to discuss the third example, Nana. Third example, see here, third one. So third example, NO plus 2. NO plus 2. See here, in NO plus 2, first we have to find the number of electrons. So here, NO plus 2, nitrogen atomic number is 7, oxygen atomic number is 8, Nana, and here charge is plus 2 is there. So that means 2 electrons lost. So that's why we have to subtract 2 electrons. So 7 plus 18, 15 electrons, Nana, minus 2, then total how much we got, students? 13 electrons we got. Clear? So total number of electrons in NO plus 2, 13 electrons. Now coming to the electronic configuration, 13 electrons. Next, electronic configuration, 13 electrons also. Here already I told you, this is also 13 electrons now. So what is the what is electronic configuration? As it is you will get. Are you clear? So up to 14 electrons, electronic configuration as it is you have to write, students. Up to 14 electrons, write that electronic configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p y2, pi 2p z2, next sigma 2p x1. Clear? So this is the energy, this is the electronic configuration completed. Now here again what happens, students? Now magnetic behavior, bond order also should come, have to calculate now. So what is the bond order, students? Again 13 electrons means it is bond order how much, Nana? 13 electrons there means bond order is 2.5. Clear? So as it is you can take, Nana, 2.5. This table, everything in the previous video I discussed with students. If you want, Nana, this table, please once you go through that, there need last year papers bits also I discussed you, Nana. Okay, now then you can easily understand. Okay, next, coming to the bond order, students. Coming to the bond order, how much in a bond order? Again 13 electrons means 2.5 only na. So take here directly 2.5, 2.5. Coming to the magnetic behavior, what is the magnetic behavior, students? Magnetic nature. What is magnetic nature? Here total number of electrons 13, it is the odd number, so that's why odd number is nothing but paramagnetic in nature. Clear, Amma? It is a paramagnetic in nature, paramagnetic. Clear? So next, Nana, fourth example, see students, fourth one, N2. N2 molecule. So in N2 molecule, so total number of electrons, how many, students? Nitrogen atomic number is 7. 2 nitrogen atoms are there. 7 plus 7, total 14 electrons. 14 electrons, 14. Okay, next one, electronic configuration. So it is 14 electrons, that means up to 14 electrons. Are you understanding? Up to 14 electrons. We have to follow the energy increasing order, this only, up to 14. Okay, so how to write electronic configuration? 14 electrons there means sigma 1s2, here 2 4 6 8 10 12 14. Are you clear? So till here you have to write the electronic, you have to fill 2 electrons in each orbital. Okay, now see here what you will get, students. Sigma 1 s2, sigma star 1 s2. Clear? Sigma star 1 s2. Next what you have to write, sigma 2s2, sigma star 2s2. Next pi 2p y2. Next pi 2p z2. Next one sigma 2p x2. Clear? Sigma 2p x2. Okay, Nama. So this is the electronic configuration. Now coming to the bond order, Nana. How to calculate, Nana, bond order? See here, bond order. How many electrons there? 14 electrons, na? So see this table, 14 electrons there means what is the bond order value? 3. So directly you can write bond order value 3, Nana. Next one, magnetic behavior. What is the magnetic nature, students? Magnetic nature is, it is even number of electrons kada, 14 electrons, it is even number, correct? It is even number. So even number of electrons, what, students? Even number of electrons, what I told you, diamagnetic in nature, except 10 and 16. So it is 14 electrons even number, so that's why it is diamagnetic in nature. Clear this one? Diamagnetic. Understood, Amma? Diamagnetic. Now see, students, next example, fifth example, Lana. Fifth one, NO plus. NO plus. NO, already NO plus also, it is same 3 bond order, same thing. I will take another example, students. O2 plus. O2 plus. Now see here, in O2 plus, how many electrons there? First you have to find it. How many electrons there, Amma, in O2 plus? Now calculate, students. In O2 plus, how many electrons? Oxygen atom, atomic number is 8. 2 oxygens there, so that's why 8 plus 8, 16 electrons. But here 1 electron lost, so that's why minus 1. Total 16 minus 1, 15 electrons. It is the odd number. Clear? Odd number. Keep in your mind, it is odd number, students. Now we are going to write the electronic configuration. Now see, students, it is 15 electrons, it is having 15. That means till now we discussed up to 14 electrons. Now we are going to discuss the after 14 electrons electronic configuration. Now see, students, this is after 14 electrons. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2ps, pi 2p, pi 2pz. This is the energy increasing order, students. Now here 15 electrons we got. That means here 2, 4, 6, 8, 10, 12, 14, 15. Are you clear, students? So here like that you have to write the electronic configuration. Now see here, electronic configuration. Sigma, how to write, Amma? Sigma 1s2, sigma star 1s2, sigma 2s2. Next sigma star 2s2, sigma 2p x2. Next pi 2p y2, pi 2p z2. And last one is pi 2p z2. Here 4, 6, 8, 10, 12, 14, 15 is there, na? So 15 where should write, where we have to take, students? Total how many electrons? 15 electrons there. So 2, 4, 6, 8, 10, 12, 14. Okay. Till here 14 electrons there. Sigma, this is which one, students? After 14 electrons, na? So pi star 2p y1. So till here you have to write, students, pi star 2p y1. Clear? So like this you have to write the electronic configuration. Now I am going to calculate the bond order. So here total 15 electrons there. 15 electrons means exactly opposite 15 electrons. How many? What is the bond order, students? bond order how much, Nana? 15 electrons, 2.5. Clear? So that just you write 2.5 bond order. Next one, magnetic nature. Now coming to the magnetic nature, students, what is the magnetic nature here? Paramagnetic or diamagnetic? It is odd number, na? So odd number is nothing but paramagnetic in nature. Clear? It is paramagnetic. Okay, paramagnetic in nature. This is O2 plus example, students. Now I am taking the O2 minus 2. Next, sixth example, students. Sixth one, O2 minus 2. Okay, O2 minus 2. Here also first you have to find the number of electrons in O2 minus 2. Nana, 2 oxygen atoms are there. So that's why atomic number is 8. 2 oxygens means 8 plus 8. Next here 2 electrons gained. That's why plus 2. Total how much, students? 18 electrons. Clear this one? Total 18 electrons, O2 minus 2. Now coming to the electronic configuration, 18 electrons. How to write, Nana? Electronic configuration? Electronic configuration. So this is 18 is nothing but it is after 14 electrons only, na? So how to write? 2, 4, 6, 8, 10, 12, 14, 16, 18. Clear? So till here you have to write the electronic configuration. Understood, Amma? So here see I am writing sigma 1s2. Okay, sigma 1s2. Next, sigma star 1s2, sigma 2s2, sigma star 2s2. Next, sigma 2px2. Next, pi 2py2, pi next one, pi 2pz2, pi 2py, pi 2pz2. Okay. Till here, how many electrons, students? 2, 4, 6, 8, 10, 12, 14, 16, 18. Pi star 2pz. Till here, you have to write. Next here, pi star 2py2. Next, pi star 2pz2. So, this is the electronic configuration, students. Like this, you have to write. Now, coming to the bond order. Bond order. Now tell me, students, what is the bond order? Total 18 electrons there. So see this table, 18 electrons means bond order value is 1. Clear? So bond order is equal to 1, students. Bond order is equal to 1. What is the magnetic nature, students? Magnetic nature. Now what is the magnetic nature, Nana? Total 18 electrons. It is the even number. Correct? It is even number. So even number of electrons diamagnetic in nature. So it is diamagnetic in nature. Clear this one? It is diamagnetic nature. Okay. It is diamagnetic nature, students. Clear, Amma? Now last example, students. Seventh one. Seventh one I am taking, Nana. Ne2 molecule I am taking. Ne2 neon. So in Ne2 molecule, students, total how many electrons there are in neon? Atomic number is 10. Two atoms are there. 10 plus 10 how much, students? 20 electrons. Total 20 electrons. Now coming to the electronic configuration, 20 electrons. So that means after 14 electrons, 20 means 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So all orbitals you have to fill with 2 electrons only. So sigma 1 s2, sigma star 1 s2, sigma 2 s2, sigma star 2 s2, sigma 2p x2, pi 2p y2, pi 2p z2. Here no need to write equal to, students. The next one, pi star 2p y2, pi star 2p z2. Next, sigma star 2p x2. Clear this one? So just you have to fill all orbitals 2 electrons, students. So this is the electronic configuration. Now see, students, bond order. What is the bond order here? Total bond here 20 electrons there now. So 20 electrons there means in table what is the bond order value? 0. So that means bond order is 0. That means the molecule does not exist. Clear? Bond order is 0. Now coming to the That means Ne2 molecule does not exist because Ne is the noble gas element. In the atomic state only it is stable. In the molecular state it is unstable. Now coming to the magnetic nature, students. What is the magnetic nature, Nana? Ne2 molecule, total 20 electrons are there. 20 electron is even number. Even number is nothing but which magnetic nature? Diamagnetic in nature. Diamagnetic. Clear? Understood, students? So please, these two tricks very important, students. This table, okay na? And after that, after 14 electrons, electronic configuration up to 14 electrons, and one more is magnetic nature, okay na? So this all very important, Nana. So this just you remember this all the tricks, then you can easily answer any type of question, students. Thank you very much, students. Okay, I hope you understood this video. If you like this video, Nana, please like, share, comment and subscribe my channel, students. Thank you very much, students.